Good morning, friends. Welcome to Chilly Morning. And in continuation of my earlier lecture, today we will understand the interpolymer force of attraction, its type, and its formation. In this category, the first one is van der Waals forces. They are formed between atoms along the length of adjacent polymers when these are less than zero point 0.3 nm apart, but no closer than about zero point 0.2 nm. Now, in this case, the bond energy or bond strength in kilojoules is 8.4. The relative strength, if we measure, it's very weak, and it is occupied in all the fibers. And what is the importance of this van der Waals forces? They are the only interpolymer force of attraction existing in the polymer system of polyethylene, polypropylene, polyvinylidene chloride, primary cellulose acetate, and 100% polyacrylonitrile. They are considered to be the predominant interpolymer forces of attraction in the polymer system of acrylic, mod acrylic, and polyester fibers. The second type of interpolymer forces is hydrogen bonding. It's formed between hydrogen and oxygen atoms and hydrogen and nitrogen atoms and adjacent polymers. When these are less than zero point 0.5 nm apart, and we have to note the hydrogen oxygen bonding is stronger than the hydrogen nitrogen bonding. The bond energy in this case is 20.9, relative strength is weak, and it occurs between the polymers of natural regenerated cellulose, nylon, polyvinyl alcohol, polyester, protein, and secondary cellulose acetate fibers. Now, regarding the importance of these interpolymer forces, that they are mainly responsible for the tenacity and the elastic plastic nature of the natural regenerated cellulose, nylon, protein fibers, polyvinyl alcohol. They contribute significantly towards the heat setting property of nylon and protein fibers. Hydrogen bonds occurring in the polymer system of polyester fibers are very weak and not considered to be important. And insignificant hydrogen bonds are formed in the polymer system and the secondary cellulose fibers. There is doubt about hydrogen bond formation in the polymer system of acrylic and mod acrylic fibers. So friends, how the interpolymer forces of attraction affects the tenacity, affects the setting property. So these are some of the points. Now then the interpolymer force type is salt linkage. Now it is a formed between the carboxyl group on one polymer and the positively charged or protonated amino group in an adjacent polymer where it is less than zero point 0.1 nm. The bond energy is 54.4, relative strength is strong, and it occurs between the polymers of protein and natural nylon fibers. They contribute towards the tenacity of the fiber, attract water molecules, hence enhance the hygroscopic character or nature of the fiber. Attract the anion of acid dyes. They are very good dye sites, may make the fiber polymer system liable to chemical degradation. So friends, this is the role of interpolymer force on the properties of the particular fiber, and that's why they affect the end use of the particular fiber. Then comes the cross links. They are formed as a single covalent bond between adjacent polymers of wool due to the disulfide bond or cross links, also formed in elastomeric. Now bond energy in this case is 245.3. The relative strength is very strong and it occurs between the polymers of all protein fibers except silk and elastomeric fibers. Now, what is the relative importance of these crosslinks? They contribute significantly to the elastic nature of elastomerics, contribute towards the tenacity of wool, are broken and reformed under controlled conditions for heat and chemical setting of wool and other protein fibers, but not silk. So, friends, today I think we have cleared the doubts about the interpolymer forces, the role, the energy, the strength, and in which polymers it occurs, and what is the relative importance of these forces. So again, I summarize that the interpolymer force of attraction, the classification is van der Waals force, hydrogen bond, salt linkage, and cross link. Thank you, friends, for watching my video, and wait till the next video comes. Goodbye.